counts the number of claims per customer. So given driver ID, group by driver ID, count the number of claims. And now that we have this table or relation, we can say claim counts, find me the maximum of that. Okay. Now that was your grouping and aggregate operations. We also talked about modifying relations, right? So in relational algebra, remember that we can add values to our set of rows and assign it back. We can delete some values from our, delete some rows from our relation and assign it back. Or we can also modify the rows by projecting out certain columns, right? In case of relational algebra, always remember to include unmodified rows. So remember that $10,000 example that we had. Transfer $10,000 to all the people in the Horseneck branch. Right. So if we wrote this relational algebra as a query as this, so branch equals select branch name, branch city, assets plus 1,000 plus 10,000 from the branch table or for all branch city Horseneck. Now this is fine, but this means that I'm going to select all the rows that have the branch city Horseneck, add $10,000 there and assign it back to branch. That means that all other branch rows are going to be deleted, right? Because we are selecting only those Horseneck branches and assigning and modifying it back. So in case of relational algebra, we need to also include all the rows that do not pertain to the Horseneck branch as well, using an union operation, right? Okay. And let me just drive it home again. SQL and relational algebra are different, mainly because SQL is multi-sets, tables are relations. If we really want to have set outputs or basically non-duplicate outputs, we can use select distinct. There are certain SQL operations that do eliminate duplicates on their own. These are mainly your set operations, right? So union, intersect, except, and so on. Okay. That's fine. Joins. Okay. So we talked about joins a bit. Now let's talk about the differences between natural join and those things. So, okay. So I am going to ask you guys this question one by one. Yes, very good question. So unique is sotaha. Distinct is get me all of those values and remove duplicates. Unique means essentially we are asking the other way around. So is there anything there? Or is there duplicate or not? So in a sense, distinct gets me rows, unique basically returns a Boolean value. So they are similar in that sense, but they are used in different approaches. Unique would get me whether it's a unique value or not, so a question mark kind of. Whereas distinct would get me, yes, and distinct would get me those individual rows. Okay. So this is one confusion that I really want to clear up for you guys. Let's see. Okay. Let's go back to this example that we were having, right? Okay. So can we write something? So remember that we said number of loans for each customer left natural join loan, right? So what happens if we remove this natural keyword from this list? Are we allowed to remove this? And what happens if we are allowed to do this, or are we not allowed to do this at all? Tell me. And that applies for the same as, and while you guys think about it, that applies to right join, and full join is not there. So left and right. Okay, so this is the thing that I thought you guys would be a bit confused about. So whenever we say that something is a natural join, we are saying that for all common attributes in R1 and R2, we are going to use those attributes to eliminate duplicates, right? So, I mean, this is something else, but essentially we are going to look at all common attributes in R1 and R2, all of them, all of them, and then use that to correlate my tables, right? So that is the definition of a natural join. However, if we say that something is a join on something, on means that we are performing a theta join. A theta join can mean anything. It could mean any particular query. Here we are saying where, so on R1.a equals to R2.a, right? So you can imagine the case where let's say that R1 has, let's say, A comma B comma C attributes, right? R2 has, let's say, A comma B comma D attributes, right? So if we perform a natural join, can you guys tell me out of A, B, and C, which of the attributes will be used to correlate these two tables? Will it be just A? Will it be A and B? Will it be ABC or just B or just C? What? Which attributes will we be using if we performed a natural join between R1 and R2? Edward, why would it be C? Because C is not there in my R2 table. Let me zoom in a bit. C is not there in my R2 table though. How can I perform a natural join? Remember, natural join only looks at common attributes, and this C is not there. So I'm saying not, I guess I understand your confusion. I'm not saying what will be the resultant table. I'm saying what attributes will a natural join use? Yes, exactly. What attributes will the natural join use in order to correlate the two tables, right? A and B. Now, that is the case for a natural join. Now, if we say R1 join R2, but let's say that we do not want both A and B. So we said that this was both A and B, right? So let's say that we do not want A and B to be used to correlate the tables. Let's say that we just want to use A. Natural join will not allow us to do that. But if we can use the or operator, we can say R1.A equals to R2.A, right? So that is where your on operator or your theta join comes into play. We can specify what conditions we are going to use to join these two things, right? And that is also very powerful. We can also say other things. We can say R1.A equals to R2.B, right? So that is get me all the values of A that are common in values of B. Maybe there is a table like that. And we want to join like that. So a theta join allows us to join using any condition. So a theta join version of the natural join would be, let me ask you this, what would be the theta join version for the natural join? Would it be something like R1 dot A equals R2 dot A and R1 exactly, right? R1 dot B equals to R2 dot B. Exactly. And that is the join operation, that is natural join on, and we have the using keyword. The using keyword basically specifies which columns we want to correlate. So essentially, when I say using A, the A attribute for R1 and R2 will be used to join those two tables, which is the same thing as saying this thing. But remember that our theta join is a bit more general, right? And a natural join specifies that all common attributes need to be used, irrespective of whatever condition you might have had. Okay. So that was your inner, left, right, full outer joins and cross joins. What else? We also have self join. So sometimes we would like to join our own table. Remember, we had the example for the manager ID. So get me all the information where manager ID equals to my employee ID. So get me all the information about the name of each employee and their boss. So that is something where a foreign key can reference to its own table. We talked about subqueries a lot. Mm. Yes, and one thing to remember, so let's say that we have find the name and city of the branch that has the least assets. So we have a subquery that is select min assets from branch, and then then we can say where assets equals to this thing, and then we can say that branch name, branch city from branch, and this requires a subquery, right? Because we need to equate it to that value. We can't just say assets equals to min assets somewhere here, right? We need to have a separate subquery to compute the min asset value. Note that we are using the equal to sign. The equal to sign is when we are comparing a scalar subquery, right? A single value is to be compared. In is basically use the in. That is used to check for a list of results whether my current row is within that list of results. That is for in. Any, some, all. These are all for comparing a value to a set of values, right? We do not need these any, some, all, in, these things when we are comparing to a scalar query. Okay. We also have the where clause. And again, we have the between thing that is fun. And not equal to is basically this particular thing. But remember that null is weird when we are talking about conditional checks. Something equal to null is undefined, something not equal to null is undefined. So for those, we would use is null or is not null. And we also have between. Let's see, is it right? Okay. Let me quickly wrap up. So we have, so another thing that we need to keep in mind is select from where we have those things. And we have this group by operations, right? So we can also perform group by operations on certain attributes. Now, remember all of those situations where, let's say that get me all the accounts where the balance is the max balance, right? So we cannot use the where clause with grouping operations because the where clause is applied before the grouping operations. But the corresponding clause for selecting rows, where is basically selecting rows, right? So the corresponding query for selecting rows after the grouping operation is the having clause, right? So remember that the where clause is applied before grouping, while the having clause is applied after grouping. Apart from that, both of those two things are the same thing. They are just used to select sub rows. They can have subqueries, they can have conditions, everything that where can